So good morning everyone, and I think today at least we are starting not so late, but a bit late. And late is not a quality that I like. It's the worst quality that we can have to start late. Anyways, I guess there are things that are not in our control. Anyways, let us first recollect what we are going to do. And in this class, we will be finishing the theory part of units and dimension. And by the next class, we will be doing all your PYQ. Do you know what is the meaning of PYQ? Any idea what is PYQ? PYQ is known as previous year questions. Anyways, this is what we were discussing in the last class. We were discussing how we can use dimensional analysis to find out or to express any quantity in terms of given physical quantities. Do we remember this? Can I have raised hands from everyone that we remember this? Okay. Now, what we'll do is this is the fifth use. We have seen the example of this. We will go on and write some important note. And this is not as important note. You can write it at point number 6. The sixth use of dimensional analysis. And this use should have been done with the first use. Do you remember what was the first use of dimensional analysis? Do you remember what was the first use? Can you tell me what was the first use that we did? First use of dimension analysis. Tintal, you can speak, right? Tanaka, you cannot speak. I can see you. So one can speak, can't be seen. One can be seen, can't be spoken to. Irony of the fact. Yes, Chintal, what was the first use of dimension analysis? Now everyone must be looking in their notebooks and finding out what was the first use, right? Tell me, Chintal, what was the first use of dimensional analysis? The first point that we did. Your audio is working fine? Video is not working. Is the audio working? No response. Sad. Anyway, the first use of dimension analysis was to convert quantities from one unit to the other unit. Now, this sixth is a different variation of the same point, but it may be done in a slightly different way, and that is why I have taken it as a different point to convert physical quantities, and this is same as, you can write, this is almost same as point number 1, to convert physical quantities from one system to other. This is same as point number 1, but this is another way of doing point number 1. You can say this. Now, whenever we are doing it in this way, what you got to remember is this simple point, which I am going to write: N1 U1 is equal to N2 U2. N1 U1 is equal to N2 U2. This is one way of writing it, or I can write it as, why this happens, or you can write it as N into U is a constant. N into U is a constant. Now, the point is, and the question is, what do you mean by N and what do you mean by U? And I must get the answer from you. What is N1 or N here? And what is U1 or U here? Yes. What is N1? What is U1? What is N? What is U? Well, I see it seems that the mic is not working anywhere. Anyways, I will tell you N1 stands for the numerical value. N1 stands for the numerical value and U1 stands for the unit. N1 into U1 should be equal to N2 into U2. A very simple example of this is if I write 1 meter on the other side, it will be equal to 100 centimeters. Now, this 1 is actually your N1. This M is actually your U1. This 100 is your N2. And this centimeter is your U2. Do we understand this? So, using this concept, what we can do is, if we create a new system, we can convert from one system to the other system. This is, as I said, basically same as point number 1, but it is just done in this way. So the basic concept of this entire thing is n into u is a constant. I hope everyone understands this. There is no way to communicate with the Chintal center, so I will go with what the other center says. Do you understand this? Yes or no? Okay. Since you understand this, let me give you a problem on this and we will discuss and we will solve this problem. So question number 1, in a new system, m dash is equal to 100 m and s dash is equal to 1 by 10s. What do we mean by m here? M here stands for our meter, or SI, original SI unit. What does S stand for here? M stands for meter, our SI unit, and S stands for seconds, our SI unit for time. Do we understand this? Now in this system, find V dash if original, spelling is wrong, original value is V. What is V? V is our velocity. Original velocity is V. What will be the new velocity V dash? So whenever I'm using this dash, this is my new system. In this new system, new meter is meter dash. New meter or meter dash is equal to 100 times of original meter. New second or second dash is 1 by 10 of the original second. What will be the new velocity V dash in this system? Is the question clear to everyone? So that is question number 1. Also find the next question, part B. If this is part A, find A dash in terms of A. What is A dash now? A dash would be my new acceleration, A being the original acceleration. So I've given you 2 problems in one problem, and now I will wait for you to solve it. I'll give you 2 minutes. Tarnaka Center, whenever you are done with this question, please tell me if it is done so that I can move forward. 1 minute and I will keep quiet for that minute, which I normally don't do. Remember, kids, it's important that you do the problem with your own hands. Then only you will get enough confidence that you can do it in the examination hall. So I'm giving you time so that you can do it yourself. That will give you a lot of confidence. Let me know when it is done. Okay, it seems we have done. Let's see how we are supposed to do it. Let's solve. I hope everyone can see the board. How are we going to solve this? Now, we know that my uh, original velocity is meter per second. Yes or no? My original velocity would be meter per second. My new velocity would be meter dash per second dash. So far, so good? So far, so good? Now, it is very simple. Now, you can either apply the formula N1 U1 is equal to N2 U2, or you can simply do it. Because now I can just put the value of M dash. M dash. How much is M dash? M dash is M dash is M dash is 100 times M divided by what is my S dash? My S dash is my S dash is 1 by 10 times of second. So 1 by 10 times of second. Now it is a simple division. 100 divided by 1 by 10. So I will get 1000 times meter per second. Do we understand this? Now meter per second, as you can see, my dear friends, meter per second is my original velocity v. So, my dear friends, the simple answer is my new velocity v dash will be 1000 times of the original velocity v. Oops. Do we understand this?
Yes, sir.
Alright, I got voice from where? Okay, wherever the voice come, this is the voice of God. I don't know from where it is coming. There was a concept in ancient India which was known as Akashvani. Was known as Akashvani. Akash means sky, Vani means voice. So Akashvani. So when God speaks, you don't see God, but He speaks. Akashvani. So Akashvani. V dash is thousand times V, but that is only, dear friends, problem number A. What is problem number B? Now, problem number B becomes pretty simple because now I know acceleration. The original acceleration was meter per second square. Tung, tung, tung. My new acceleration would be A dash. That would be meter dash divided by second dash square. I will again just put the values of meter dash. My meter dash is 1000, no, 100 meters. My second dash is 1 by 10 second ka whole square. Remember now it is squared. So 1 by 10 becomes 1 by 100. That 100 goes into the numerator, my dear friends. And the new answer that I get is 10,000, 10,000, 10,000, 4 zeros meter per second square. So my new acceleration is 10,000 times the original acceleration. Did you get all the two options correct? All the two questions correct? Huh? Why? It was as simple as this. In velocity, we did meter by second. In acceleration, we just had to do meter by second square. Nothing else, nothing more, nothing less. Have you understood this?
Yes, sir.
Well done, sir. How many? Okay, I can't see you. So I am not omnipotent and omnipresent because I can't see all of you. I'm, what do I call myself? I'm handicapped today. My eyes is not working properly, so I can't see all of you, and I'm not present everywhere at the same time. Don't worry, I will gain my majestic powers very soon. As soon as your camera start working, I will get my power back. Anyways, let me come to another question. And remember, the questions that we are doing, my dear friends, they might be, and you will see the type of question that actually come in your NEET exam. Type of question that come, they are pretty simple compared to what we are doing. But since we are doing tough ones, if a question which is easy comes, you will find it like a cakewalk, and that is why we are doing this question. So here comes the next one. This is taken from a JEE wala paper. If the present unit of length, time, and mass, present unit is meter, second, and kg, are changed to 100 meters. So new meter becomes 100 meter, new second becomes 100 seconds, and new kg becomes 1 by 10 times of kg. Then they're asking us 4 questions. Question number 1, what is the new velocity? We have to find out each and every one. Question number 2 is find out the new force. Question number 3 is find out the new energy. And question number 4 is finding out the new unit of pressure. Now remember, this is a single option correct question. Only one of the options is correct. To get the correct option, tell me which is the correct option. Do we understand this question? Can you do it? Yes or no? No or yes? So, my dear friends, fellow people, fellow earthlings, your time starts now. Yes, my dear friends. Any answer? Anyone got? This is what? A, 2 is B, 3 is C, and 4 is D. Hmm. Which is the correct option? 1, 2, 3, 4. Which is the correct option? Huh? Don't know it? 1, 2, 3, 4. 1, 2, 3, 4. Which is the correct option? Arey, what are you doing, beta? Tell me. Tell me fast. Which is the correct option, my dear friends? 1, 2, 3, 4. Did you get? Were you able to solve the question? Yes or no? Yes. So what is the correct option? 1, 2, 3, 4. I can't see your fingers, small fingers. 1, 2, 3, 4. 2. 2 is the answer that I got. Let us see if that is the correct answer. I think so. Solution. What you got to do? Let me start with option A. I have to find out the new velocity. I repeat my steps. My original velocity is meter per second. I move on to the step 2. My new velocity v dash will be meters dash by second dash. That will be new meter is 100 meters, new second is 100 seconds, and 100 and 100 gets cancelled. So my new velocity is meter per second. That is the same velocity. Option number 1 says it has increased 10 times. That is definitely not the right answer. Therefore, option number 1 goes down the drain. Don't have to worry about option number 1. This is absolutely wrong. Everyone got this? Then I move on to the second option, which I will do in green. This one. The new unit of force. Let me write the original unit of force, my dear friends. Original unit of force. That is why you need to know their dimensions and their units, my dear friend. The original unit of force is kg meter per second square. That is the original unit. The new unit becomes f dash. That becomes my kg dash meter dash divided by second dash ka square. As simple as this. I just now put the values, my dear friend. What is new kg dash? It is 1 by 10 times of kg. So 1 by 10. What is the new meter dash? That is 100 times of meter divided by, my dear friends, new second dash, which is 100 times second whole square multiplied by original kg meter per second square. Now you can easily multiply, divide, and see what is coming. This is a simple multiplication and division, which I am not going to do for you, which you are going to do, and you will find out that new f dash will be coming as 1 by 1000 into kg meter per second square, which is your original f. And as you can see, my dear friends, this option is definitely matching with your option number 2 or B, and therefore this is the correct answer. We don't need to go any further because the other options are wrong. How many of you got this answer? Please raise your hands. Well done. We shall do one more question on this so that everyone gets in sync. This is the last of this category, and I hope that all of the students over here, my students, will be able to solve this one, which is coming on your screens right away. Question number 2 on this. Oops. Question number 2, and here it comes. Hoi. Suppose we employ a system in which unit of mass. Oh, Mass has become 100 kg. Original mass is kg. New mass is 100 kg. The unit of length becomes 1 kilometer. Ooh. And the unit of time becomes 100 seconds. And we call the new unit of energy ELOG, which is joule written in ulta order. This is just comedy. So the new unit is ELOG, ulta of joule. What is ELOG in terms of original joule? And my dear friends, your time, which is running very fast at 60 minutes per hour, 60 seconds per minute, starts now. And I hope you make the best use of this time that you get. And my dear friends, do we have an answer? Here. One, two, C, D. A, B, C, D. Which is the correct answer? No one? Not good, not good, not good. One, two, three, four. Do I see the small fingers coming up? Yes. Vote. This is how you vote. Number one is the voting right, and that is how you vote. And number one is, I think, the correct answer. How are we going to do this, my dear friends? Solution, it's very simple. I first of all, I need to look for the original unit of energy. The original unit of energy is kg meter square per second square. That is the original unit of energy. Yes or no? That tells me that the new unit of energy E dash will be equal to kg dash meter dash square divided by second dash ka square. As simple as this. Now I just put the values here. New kg dash is 100 times of kg, so 100 multiplied by new meter dash is 1 kilometer. 1 kilometer is 1000 meters, so 1000 ka square divided by new second dash is 100 times of second, so 100 ka square. This is a very simple calculation. You can do this, yes or no? This is a very simple calculation, and that will give me my new energy E dash as I think 10 raised to the power of 4, the original energy. And then I just need to look at which option is matching this one, and no problems for guessing this. The option that matches is option A, and option A is our answer. Everyone got this?
Yes, sir.
Well done, sir. Then that means that we are done with the numerical wala part here. Now, remember, the next thing that we are going to do is the limitations of dimensional analysis. Now, remember, my dear friends, the question from the next part may not come as direct questions. They may come as indirect question, and one of those indirect question I had put in your test. You have to understand how you use this theory part, the limitations, and how are they asking questions, and how do you match up. That is what you need to understand, my dear friends. So let us now move on and write the last heading for this particular topic, and that heading is limitations of DA. I hope you understand the meaning of DA. DA stands for, my dear friend, dimensional analysis. DA stands for dimensional analysis. What are the limitations? And if I may ask, can you tell me any limitation that you find in dimensional analysis? What limitation do you find in dimensional analysis? Can you think of a limitation, anyone? I think, I mean, one class can speak, the other class I can see. Can anyone tell me, can anyone think of any limitation that you see, that you find in dimensional analysis? Any limitation? Any limitation in dimensional analysis? Okay, let me start with the first one, and I will start point by point, so that when we are going through this limitation, my dear friends, we will be sort of going through the entire chapter and making some points out of this, and probably we'll be looking at those points in a different light. The first limitation is, if dimensions are given, if dimensions are given, the physical quantity means PQ, may not be unique. May not be unique, as different physical quantities can have same dimension. So just by looking at the dimension, we cannot say with confidence that okay, that dimension is this, the quantity would be this. Let me give you a very simple example of this, and we know this example: work, energy, and torque. They all have the same dimension, my dear friend. and the dimension is ml square t minus 2. Now the problem is, if you get a physical quantity which has this dimension ml square t minus 2, you cannot say with absolute confidence which quantity you have got, whether you have got work, whether you have got energy, or whether you have got torque. So that is the problem. So that takes us to the actual point that physical quantities may have different dimensions. I have put the same point in a different way. Do we understand this? Yes or no? No, yes. We have been doing same things over and over again. And remember, these simple things will be coming in your examination hall. I hope everyone has written this. Yes or no? No, yes. Point number one. Point number one. Number one limitation of dimensional analysis. Let me move on to number two. Numbers don't have any dimension. Number do not have any dimension. Therefore, they cannot be deducted using dimensional analysis. Numbers do not have any dimension. For example, this implies that exact formula can't be derived. We had seen we had seen we had seen that using dimension analysis, point number 4, we can find out a rough formula. We can only find out that rough formula, and we cannot find out the exact formula because numbers don't have dimension. Do we understand this? The example for this is very simple. T is equal to K times root over L by G. We had done this question, yes or no? We had derived this formula for time period. In this, K, your K is a number that cannot be found. Do we understand this? K was a number, it could not be found. This number could have been 1, 2, pi, anything. We cannot find out the exact formula for a physical quantity because the number that comes in that quantity does not have any dimension, and that number cannot be determined. Do we understand this? Yes or no? No, yes. Can I have some raised hands?
Yes, sir.
Well done, sir. Okay. Now, I hope everyone has written this down. Point
Yes,
number,
sir.
okay. That takes us to point number 3. Now, point number 3, if a physical quantity PQ has sine, cosine, log, or exponential functions. Now remember, all these 4 quantities, sine, cosine, log, exponential functions, they are all numbers. Do we understand this better? They are all numbers. Now, if a physical quantity has all these sine, cosine, log, or exponential functions which are numbers, they cannot be determined. They can't be determined. They can't be found out using dimensional analysis. For example, y is equal to a sine omega t. Now, this is equation of a simple harmonic motion, my dear friend. Simple harmonic motion will come, it's 9th or 10th or 11th chapter, depending on how we are counting the chapters. Y is equal to a sine omega t. This is the formula of displacement in a simple harmonic motion. Now, this particular expression, this particular equation, this particular formula has sine coming into it. This entire thing has sine. Now, this formula cannot be derived using dimensional analysis. Do we understand this? Similarly, any formula which has sine, cosine, tan, log, for example, if I had a formula like this, velocity is v naught log of lambda t. Again, this has a log function. We cannot derive this formula using dimensional analysis. Dimensional analysis cannot help us in deriving a formula which has sine, cosine, or any other number. If it has a number, we can only get a rough formula. If it has sine and cosine, we'll again not be able to derive it. Do we understand this? Yes or no? This is the third limitation of dimensional analysis. I hope everyone is noting this down, yes or no? Now
Yes,
remember,
sir.
no one is going to ask you straight away, tell me the third limitation of dimensional analysis. No, they're not going to ask you a question like this. We'll make the question in such a way that you will have to apply this concept and then tell which answer is there, which answer is correct, or which answer is wrong. I will make a question, I will find a question and I'll put it to you. Don't worry. Let us first finish this entire limitations. Point number 4. Point number 4. Dimensional analysis is only useful. Dimension analysis is only useful when a physical quantity PQ depends only on multiplication or power functions. It is only useful when the physical quantity depends on the multiplication. It is not useful. It is not useful if physical quantity has sum or subtraction. The physical quantity, if it has sum or subtraction, that means we cannot derive it. It can't be derived using dimensional analysis. What I mean by this is, for example, if I have F is equal to mass raised to the power of x, velocity raised to the power y, and let us say acceleration raised to the power of z. It depends on the multiplication. It depends on the multiplication of three quantities. Therefore, for this particular case, I would be able to derive the relation. I will not be able to get the number, but I will be able to derive the relation. But if I have a quantity which has some coming in it, for example, S is equal to UT plus half AT square. In this case, my dear friends, I can only check whether the equation is dimensionally correct or not. Can I derive this equation using dimension analysis? Can I derive S is equal to UT plus half AT square using dimension analysis? And the answer is this equation cannot be derived using dimensional analysis because it has plus or minus coming into it. Do we understand this? This equation cannot be derived using dimension analysis because it has plus or minus coming into it. Do we understand this?
Yes, sir.
Everyone understand this? We can only use it for multiplication and powers. We cannot use it for addition and subtraction. If addition and subtraction come, you can only check whether it is correct or not. Shall we move on to the next one? Shall we move on to the next one, beta? Everyone has noted this down? Everyone has noted this down?
Yes, sir.
Shall I move on to the next one? Now, whatever we have done, I think this is a point limitation number 5, if I'm correct. That was 4. Now, whatever we have done in the question that we have done, we have equated M, L, and T on left hand side and on the right hand side. Now, if the physical quantity in mechanics, now in mechanics we only have 3 terms coming, M, L, and T. In mechanics, remember it is only for mechanics. In mechanics, only 3 terms or 3 fundamental quantities, M, L, and T, can be equated. M, L, and T can be equated. Therefore, if a physical quantity in mechanics depends on more than 3 physical quantities, it can't be derived using dimensional analysis. For example, if I say force depends on mass, velocity, and R. If I say that force acting on a body depends on mv and r, can I derive it using dimension analysis? Yes or no? Rough formula that I'm saying, not the exact formula. Can I derive this force using dimension analysis, the rough formula? Yes or no? We have done this question. Can we derive a rough formula for force using dimension analysis? Yes, we can do this. Now, if I change the question slightly, now if I say force depends on M, V, R, and T, T standing for time. Now, if this force would have depended on 4 quantities, Can I derive this force using dimension analysis? Can I derive this force using dimension analysis? And the answer is no, because I will only have three equations, one for M, one for L, and one for T. There are four unknowns. I will not be able to derive the equation of force using dimensional analysis. Do we understand this? Have you noted down point number four? Point number five, yes or no?
Yes, sir.
Have you understood what we have discussed till now? There are two more points which I will discuss, and we will discuss it in the next class. Two small points. The majority of the points we have already discussed. Two more points left, which we will discuss in the next class. And in the next class, we will be solving all your questions together. We will be taking questions from your previous year papers and try to solve them. And you will see what type of questions actually come in the examination hall and what type of questions we have already done. So here it is. Today we have gone through the limitations of dimension analysis. In going through the limitations, if you imagine, if you realize, we have covered the entire chapter once again. Yes or no? So we will continue with our journey in the next class, and I guess in the next class we will be able to wind up this chapter of yours and move on to the next chapter. If you have any doubts, better, you can always ask me anytime. For this class, it's bye from now. Bye for now. I'll see you in the next class. Take care. Have a nice day.